Everyone, today we are discussing about the Cauchy mean value theorem, and in the previous classes we have completed the Lagrange's and the Rolle's theorems. Now it is the same like the Lagrange's, but there is just a small difference here, that there is two functions which is f and another one is g. That is the main difference, the Cauchy and the Lagrange's. Here the rules what we have to follow, the given function have to obey the Cauchy mean value theorem. Now we will see the f and g are the continuous in closed a comma b, and this is the first. Always in the every theorem it is repeating the first statement, the function it should be continuous, and the second statement also it is repeated, and f comma g are differentiable in open a comma b. And here the third statement, here the g dash is not equals to 0. Why? Because if anything by 0 that will be becoming infinity, then we are not getting the any answer. So that the third statement, that g dash x is not equals to 0 for all x belongs to a comma b, that is, then there exists at least one value c belongs to open a comma b, such that here the to find the c value there is a formula f of b minus f of a by g of b minus g of a by f dash c by g dash c. Here in the it is the combination of the Lagrange's theorem. If we add b by a by b by a by b by a, they both will be cancelled and it will be remain. And this is Cauchy mean value theorem. Now let us see some problems on it. Here is the first problem. Verify the Cauchy mean value theorem for f of x is equal to root x and g of x is equal to 1 by root x in closed a comma b, where 0 less than a less than b. Here first the f of x is equals to root x and g of x is equals to 1 by root x. These are the functions and that are the continuous in closed a comma b, and next they are differentiable. The difference d by dx of root x, that will be 1 by 2 root x, and here the d by dx of 1 by root x. That means we have to consider x power minus 1 by 2 and differentiate this, then we will get minus 1 by 2 into x root x, and here it is differentiable in a comma b. Next, how to now we can see how we find here the g dash x is not equals to 0. This is the main point that you have to remember, and the next we will see the how to find the c value. Now let us consider here the f of the formula for c, f of b minus f of a by g of b minus g of a, that is equals to f dash c by g dash c, and we are substituting the values from the given f of x and the g of x. Next, let us continue, and the f of b is equals to here b, then the function f of a is equal f of x is root x, then here it will be becoming root b minus root a by 1 by root x, the g of x is, then here 1 by b minus 1 by root a. Here the differentiation of the f of a is 1 by 2 root x, and the next by minus 1 by 2x root x. Next, on solving, we have to solve this equation. This will be cancel, and this will here not x, it will be c. Why? Because we have to find the value of the c. This will be cancelled, and here the cross multiply, and by taking the LCM, root b into root a, it will be going to the numerator, and root b minus root a by root a minus root b. Next, here what will be left? There will be only minus c. This c will be going to the numerator, and it will be the remaining. Then what we have to do next? Here, by taking the minus common in the numerator or denominator, wherever you want, root ab, whole taking minus common, root a minus root b by root a minus root b. Here the cancelling the numerator and denominator and the negative, the c is equals to, then c will become root ab, and this is the problem. And here the root c belongs to open a comma b, and this is the conclusion. Hence Cauchy mean value theorem is verified. take it as homework and do it, and later on you can find the answers in the website as follows. Take a screenshot of it, and I am going to the next question. Now let us solve the next problem. Verify the CMVT for f of x is equals to 1 by x square and g of x is equal to 1 by x in the closed a comma b, where a comma b is greater than 0. Here first we have to see the functions. These are like a polynomials and they are continuous. Yes, in closed, that means closed a comma b. Then the differentiability of the functions we have to check. Given f of x, we have to write 1 by x square and g of x is equals to 1 by x, and next the differentiating them. If we don't know differentiation, first simplify the function x power minus 1 by 2. It is in the form of n into x power n minus 1. It is the differentiate. After differentiating this function, it will be in the form here minus 2 x minus 2 minus 1 minus 2 x minus 3. Here 1 x power minus 3, it will be going to the in the denominator and then will become positive minus 2 into x power 3. Next it will be completed the differentiation, the f dash x we get same the g dash x. Next here also you convert the power into the minus 1 negative. Here minus 1 x, that means minus 1 minus 1 minus 1 x power minus 2 minus 1 x square. It is 1 by minus 1 by x square, that is g dash x. Here we completed the differentiation. Here we conclude that the second statement is also true and they are derivable where in interval, that is open a comma b. And next we have to find the value of the c which is lie between a and b. Next, for finding the value of c we have already know, but now here we have to find the f of b first. F of b is 1 by b square and f of a is equals to 1 by a square, and g of a, that is 1 by a, and g of b is 1 by b. We have no formula f of b minus f of a by g of b minus g of a, that is equals to f dash c by g dash c. By using the Cauchy mean value theorem, let's substitute the values. 1 by b square minus 1 by a square by 1 by b minus 1 by a, that is equals to the differentiation of the functions minus 2 by c cube and minus 1 by c square. By continuing them, here the LCM is b square into a square in the numerator, then a square minus b square by a square b square, that is equals to a square minus here not a square, a minus b by ab. Here then what we get here, what are the terms that are going to be cancelled? Negative cancel, and it will be going to the numerator, and there will be 1 by c, that in the RHS side. Now continuing the b square by a square b square by a minus b into a minus b. Here the powers will be get cancelled, then minus 2 by c it will be remaining, and then what we have to do here, this can be written as a minus b into a plus b by a minus b into ab here, that is equal to minus 2c. A minus b will be cancelled, and this here also negative, and here there is no negative sign, we have cancelled before steps. Here c is equals to 2ab by a plus b, and this lies between a comma b, and finally CMVT is verified. Here go on with the next problem. The verify CMVT. Here the f of x Here only the f of x is given, but they specified that f dash x, that means it is equals to the g of x in the interval of closed 1 comma e, where f of x is equals to log x. Here they specified that f of x is equal to log x, then g of x. First write the f of x is equal to log x, and g of x is equals to f dash x. What is d by dx of log x? Then we will proceed. That what is the derivative of the log x? That is 1 by x. Next go on. Here f of x and g of x are continuous in, that means closed 1 comma e. First is verified, and the next f of x and g of x are derivable in where the interval, that is open 1 comma e, 1 comma e. We have to check the derivatives. What is the d by dx of log x? That is 1 by x, that is equal to the f dash x, and the d by dx of 1 by x squared, that will be, as we did in the previous problem, the d by dx of 1 by x, that is equals to minus 1 by x square. We have already known. And next, moving on to the next step and finding the value of the c. Here also g of x is not equal to the 0. It will be the main remembering point for you. It will be not becoming 0. Next, the verification, f of b minus f of a by g of b minus g of a, that is equals to f dash c by g dash c, f of b. What is f of b here? By substituting the b value in the given function, that will be the f of b. Here f of b is what? 1 by, that is not 1 by, that is equals to log e base e minus log 1 base e by, here g of x is equal to 1 by x, 1 by e minus 1, that is equals to 1 by c minus 1 by c square. Here log e base e, it will be becoming 1, and log 1 base e, it will be becoming 0, and here doing the LCM, 1 minus e by e, that is equals to minus c, and taking this to the numerator, e minus e, that is equal to the minus c, then c is equals to e by e minus 1. This is lie between the given. On solving this, we can get 1.581, which is belongs to open 1 comma e. Sorry for the not moving in the screen. Next, here we can see e by 1 minus e square minus c. As we all know the logarithmic, and then continuing, hence CMVT is verified. Next, we will see some geometrical interpretation of the Rolle's theorem concepts. Here we can see the geometrical interpretation of the Rolle's theorem. Geometrical assumptions in the Rolle's theorem means the following: the curve y is equal to f of x is continuous in closed a comma b. This is the first statement in the geometrical interpretation of the Rolle's theorem. That means applying the Rolle's theorem in the geometry at every point. Here we can see at every point x is equal to c, where a less than c less than b at the point, and the point is c comma f dash f of c on the curve y is equal to f of x, where it is a unique tangent. Here we can see the diagrams. Here it is the point where from the point that the c comma f of c, here it is the point, then it is the curve y is equals to f of x, and the c lies between the a and b. This means the following above statements. It will be important for your 2 marks, as the scheme changed R23. It will be one of the question maybe asked in the examination by the examiner. Here f of b is equals f of a is equals to f of b. Therefore, the two end points of the curve y is equal to f of x b corresponding to the x, and x is equal to a and x is equal to b have the same ordinate. What is mean by ordinate? In the point we consider here ordinate. This is the ordinate and this is the abscissa, as like this x is equals to a, and they are the ordinates, that is they are at the same height with the reference to the x-axis. The point which are reference to the x-axis are known as the ordinate, right? And here beside we can see the another curve. Here the line, the slope, which is slope is negative in the curve, is below the above the x-axis, but it is downwards. And here also we can see the point C lies between the A and B. And next we are going to the geometrical interpretation of the Lagranges. How we apply the Lagranges in the geometry, as it is we are discussing about calculus, but it is one of the important concepts. The geometrically the two assumptions in the Lagrange's mean value theorem, here also just two. The curve y is equals to f of x, same as the above rules, here also the same. The y is equals to f of x, the same function at every point x is equals to c, where a less than c less than b at the point c comma f of c on the curve, and y is equals to f of x. There is a unique tangent, same as the above theorem what it told. And the LMVT says that where that there is at least one point on the curve and the tangent is parallel to the chord. It is the main difference between the rules and the Lagranges. Here in the before only just we discussed about the tangent, here the chord. And moving to the next, here we can see the points a comma f of a and b comma f of b on the curve, and since the slope of the c, therefore f of c is equals to the slope, that means the AB f dash c. What is the normal formula to find the c? That will be here f of b minus f of a by b minus a. Here we can see the graphical representation in the geometry. Here it is the curve, and it is the tangent drawn from the point C, and which is parallel to the chord. The diameter is one of the largest chord in the curve or circle. Just let us consider this as a circle for understanding. And we can find the slope of the chord, that means the here any chord, to find that slope f of b minus f of a by b minus a. The homework for the today's class I will show in the at the end of the video. And in the next classes we are going to discuss the Taylor series and the Maclaurin series and their theorems, and the next that it will be completed the classes, and the next chapter will be started very soon. Thank you for watching.